Welcome to Heavy Networking, the flagship podcast in the Packet Pushers fleet. I'm Drew Connery Murray. My shipmate today is Ethan Banks. Today we're going to have a design discussion about various approaches to load balancing radius servers. And this is to ensure that our guest's infrastructure can support all the clients that need to access a wireless network. That guest is Dan Massameno. He's Director of Network and Cloud Architecture at Yale University. Dan went through this process of building out this load balancing infrastructure, and he happened to write a series of blogs about it that are on Packet Pushers. We'll have links to those blogs in the show notes. But after reading this series, we thought it would be great to have Dan on to talk through what he did, why he did it, and what he learned in the process. So Dan, welcome to the podcast. Can you just give us a brief overview of who you are and what you do, and then talk a little bit about the environment you're working in?
Sure, yes. I am the Director of Network and Cloud Architecture at Yale University in Connecticut in the United States. And we are in the process of switching to SD Access, which is a Cisco product for campus networks. And a huge part of that architecture is authenticating you, whether you're on wireless or wired. I want to start by saying I do not represent my employer or the vendor. The views are expressed on this podcast are my own. But other than that, I'm happy to talk about some of the experiences and our radius system.
Okay, of course. And yes, you are representing yourself, and that's a given here, but I'm glad you said it. So the general idea is you wanted to load balance some radius servers, or in the, I guess, Cisco parlance, policy service nodes. What kind of infrastructure are we talking about? And also, what kind of performance were you looking to get?
So we have an urban campus here at the university. We're using Cisco DNA Center. We're migrating to that system from an older system of a mix of vendors. We have about 1,000 switches and 4,000 plus wireless access points on the new Cisco SD Access system. We have about 5,000 access points on the legacy wireless system that we're migrating off of. And we have about 1,000 switches still that are not on SD Access. We're tracking about more than 70,000 active sessions on Cisco ICE, which is Cisco's authentication system, identity services engine.
Yep.
Their radius server, which we might use the terms interchangeably, radius server and Cisco PSN, which is their policy services node, which is the part of the ICE architecture that actually does the authenticating of wired and wireless. I've been working here at Yale for a while, and I'm working on a team of about 18 other network engineers. It's a great team, a lot of deep bench that we are able to maintain a network of over 300 buildings here in the New Haven and surrounding area. And we have a great situation where, because we are in an urban area and have been in New Haven for so long, that we have a lot of dark fiber. And so we can treat it as a giant metro LAN. So that means we can light fiber up with 10 gig, 100 gig, whatever we can light it up with. And the cost for 100 gig optics is not a huge speed bump if you're building a backbone and you have your own fiber. So that's an awesome point for the network.
That's great that you can light up your own fiber. I used to work for a state government, and we had buildings across the capital city, but we did not own our fiber all over the city. We had lots of fiber on certain campuses, but to interconnect the campuses, it was a whole thing to get fiber laid and so on. We were like any other tenant needing to get fiber placed and so on, so that you have access to that fiber and can light it up at will, and lots of dark pairs waiting for you is pretty awesome. So Dan, you mentioned you got two PSNs. You knew what capacity they could handle. You talked about 70,000 sessions, I think you said. So with this load balancing scenario, you trying to use them both active, or is one there as a failover?
So we started with two radius servers, because at the beginning of the project, we didn't have anything going on. I mean, we hadn't done building one yet. And we built the infrastructure with two, the PSNs, the radius servers, and we just did active standby. And we did split it up so that we have 4 sites. The network's divided into 4 areas, and areas A and C use the first radius server as its active, and the second one as its standby. And sites B and D, we did it reverse. So that's kind of a poor man's load balancing, very rough cut. And we were going with that setup for a while as we started to do our first initial 3 pilot buildings, and we're ramping up and we're getting more and more. And 2 things happened. One was we're bringing on more and more buildings onto the network. Our target is 300 buildings. We're probably in a few months going to be halfway done with the project. So we're bringing more buildings on, more authentications per second, more users. So that meant we need to scale out. And the other problem, but not a problem, an engineering challenge, is that you can't plan on just the raw spec sheet of how many authentications per second your platform can do, because you get spikes of activity, and they're from natural causes like the commencement day, and there's a lot of guests on the campus, and unnatural causes, poorly written EAP supplicants on poorly designed smartphones that will just decide to get into a loop and send 10 authentications per second at you. And you can't plan on that not happening. So now you have to scale out well ahead of what we thought we were going to need and implement what we knew we had to implement ultimately, but we had to get there, which is more and more Radius servers and scale out.
Okay, so 2 Radius servers, 2 PSNs weren't cutting it. You knew you needed to add more, but you also kind of had this almost like hard-coded mechanism for distributing the load across those Radius servers, and you decided like, this isn't going to scale?
Yeah, so one phenomenon that we observed is if one Radius server started to get bogged down, it would start to, switches and the wireless LAN controllers would start to time out and hit their dead interval timer, and then they'd flip over to the other Radius server. So now all the load is flipping onto the one remaining server, and then that starts to get overloaded, and then the whole system is getting overloaded. And so it doesn't really dynamically balance well because it's not balancing on its own, and we need to scale it out. So now we're talking about 4 PSNs. Today, we're doing 6 PSNs, Radius servers, and the prescribed course of action by the vendor, Cisco, was put a pair of F5s in front of it. Cisco doesn't care if they're Citrix load balancers or A10s, but they have a lot of documentation on how to do it on an F5. And they said, this is how we've done it at a lot of other places. We were using Cisco Advanced Services, which is their consulting arm. So we had those guys in, and they were showing us, here's a design template of how to do it. And they were doing it with F5. So
it's so funny. I mean, Cisco used to have load balancers years ago. That was a whole significant product line for them. But boy, that goes back a ways.
Yeah, they were saying F5s, and you don't want to get outside the comfort zone of your vendor in terms of what they can support. So if you build something Snowflake, and then something needs to be, Cisco TAC, Technical Assistance Center, they need to look at something like, well, what have you built here? Like, that's a problem for mean time to restoration. So we did. We actually put the F5s in. So the start of the journey, we had a very, very simple system, and it had enough capacity for us. And then as we scaled out, the middle part of this journey, we put the F5s in. But I had architectural questions, let's say.
Well, yeah, I mean, my question might actually dovetail into what you're about to say, but I mean, it sounds like this would be a pretty straightforward job for an F5 load balancer to do. You're going to stick the PSNs, the radius boxes behind the F5 as pool members. You're going to build pool around them and do some health checks, then throw a virtual IP on the front, and you're going to aim your access points and so on at that virtual IP, and you're going to let the F5 do whatever the appropriate load balancing mechanism is. It's going to track what the load is on each server, and there's a whole bunch of different load balancing methods the F5 will give you. And that seems straightforward. And if you needed to scale, you just throw another pool member behind it, something like that. But maybe it's not so simple, Dan. Is that where we're going?
Well, so everything's simple as long as you keep to a 2-sentence description of. So there's actually a document from Cisco, and there's Cisco live presentations that you can watch on all the details of how to get this to actually work smoothly. So, for instance, normally you do source NAT. So as the traffic hits if you're like load balancing to a dozen web servers, your client hits the VIP, and then the F5 distributes it round robin or something to one of the web servers, and it does source NAT, changes the source IP of the packet so that when the web server responds, it responds and sends the return traffic back through the F5. But the F5 sees both sides of the TCP conversation and then sends it back to the original client. Source NAT messes up radius servers, and it messes up a feature called change of authorization, which is a feature where if the radius server decides, no, I want to change what VLAN you're on, or I want to change something about your session, it will send a change of authorization back to the original switch or wireless LAN controller to say, hey, there's been a change. It can't do that if it doesn't know the IP of the originating switch. And it doesn't know that if it's done the source NAT.
Right.
So Cisco's document, I'll say, so here's your first speed bump in terms of deviating from quote unquote KISS or simple or what we've normally done. So you can't use SourceNet, which means you got to change who the default gateway is on that subnet in your data center and do, that's only the beginning of a couple different weird things. The stickiness. So usually you just have to stick the session to the server that you're trying to load balance to, or stick it based on who was doing the originating request. But wireless LAN controllers might be doing authentication for 1,000 EPs. So that's not going to load balance if you're just sticking based on the source.
Yeah, you'll be stuck based on that. Yeah, that one box that's on behalf of all those others, and so you won't get an even distribution of those 1,000. It's going to be everybody's going to stick to the one, right? So you got to load balance on some other mechanism.
Well, there's a nerd knob for that.
Of course, there is.
Yeah, so you can go into the F5 or Citrix or whatever your platform of choice is, and inside the Radius packet, there's I think a calling station ID, which is the MAC address of the original smartphone or laptop or whatever it was. And then you can round robin from that. But you see how you've gone quickly from a simple slap an F5 in and go to town to, we got to program this thing to do a certain thing. And one difficulty we had is our network engineering group, we were thin on F5 skills. Yale is an F5 shop, so that's why we chose that platform. And it did seem that most of Cisco's documentation was for F5, probably because their customers mostly used F5s. But our cloud team was the one that was the main owner of the F5 services that are already in place. So the network engineering team bought their own pair of F5s because we really wanted to kind of own it. Oh, now we own it. And so now we got to do the care and feeding of the F5, which is above and beyond our normal, everything else that our team is doing. So that was a difficulty.
Yeah, it sounds like the F5s came in almost sort of by default. It wasn't like, let's do some testing, let's figure out what's best for us, what interfaces we're most comfortable with, which product is going to serve us best. It was like, the university itself already has relationships, and our primary vendor's documentation is suggesting this. So that's sort of what you ended up with.
Yeah, and we knew that if something went badly, down the hall is the cloud team, and their team knew F5 better than us. So we could, but they didn't want to run the project or own the service offering. They wanted us to, because they have their own 47,000 projects that they're dealing with.
Right.
Like any IT shop, probably every single one of your listeners, you're trying to fit a 50-hour bag into a 40-hour work week. And, that's how IT runs.
Yep.
I like it. It's the pace that I like to go at, but IT is an interesting beast. So we're all banging away at the projects that we are doing. So anyway, the F5 was going to be owned by the network engineering group, and it was over and above our normal tasks, which we were willing to take on. Like we were going to do this because it was necessary to scale out the Radius network. Great. Next problem was, if you put in an F5, that's a single point of failure.
Just a single F5, yes.
There's a single F5, right? So that obviously could go down and wipe out all your Radius server action. And we authenticate wired and wireless. So you'd be dead. Like the whole system relies on the authentication system working correctly. All the load balancer vendors have a solution for this, which is buy 2 of them and put them into an HA pair.
Why is it always buy another one?
Yeah, it is. Buy another one and pretend that the system's, although now it's more robust and it's also more fragile all at the same time.
Yeah, and funny enough, they don't usually have a buy one, get one free.
I worked at a big F5 shop, and we used to be like, do we actually have to license this F5 that we're not using, that sits here in standby and does nothing all the time? We actually had a discussion with our rep who laughed at us about this. But yeah, you got to license them because come on, man, I got a BMW to put gas in. What are you thinking? Yeah,
well, yeah. So you would obviously buy 2 because you don't want a single point of failure. But it's interesting design phenomenon to have 2 of something in an HA pair. It's coupled together as one logical load balancer. So you really have to think, in my network career, you really have to think hard with how you're doing these HA pairs, whether they're firewalls or load balancers or VPN concentrators. There's a lot of things that can take out an HA pair. Aside from a power supply fails and one of them goes down, I mean, you could have human error. You could have a software bug that messes up both F5s. I mean, there's a number of things that could potentially mess up both of them. It's not a given that one would survive if the other one has a hardware failure.
Did you also do redundant switches on the front side and the back side of the F5s, all that kind of stuff too?
Oh yeah, we can do that. That kind of bread and butter us network engineers can do in spades.
Yeah,
So
yeah.
that was fine. But yeah, the F5s. So we ended up deciding to put in two F5s, but not in an HA pair. Two autonomously separately configured F5s and three radius servers behind each for a total of 6. And that way I felt comfortable that no matter what happened, one of the F5s would survive.
Yeah.
That the three radius servers behind it would survive. And we put them in two different buildings. And that was starting to give me more comfort that this was a super robust, and we didn't need all 6 radius servers to run smoothly throughout the day. Probably still only needed 2, barring some big spike. But we could run on 3, even if one of them went down for maintenance or one of the F5s was down for some other reason. And so that eliminated my HA pair concern in terms of our goal.
But by not having an HA pair, you just broke them up. There's the same design argument you can have about redundant soup engines. Do I have redundant soup engines in a single switch, or do I have 2 switches, 2 chassis with each with its own supervisor engine, and kind of spread my failure out in a different way? And then there's the discussion of, well, I want 2 switches, each with a soup engine and a redundant soup engine. And then you're like, well, wait a minute. Are we just throwing money? What are we doing? Each of them's going to have 2 soup engines? Why did we have 2 switches to begin with then? Yeah, so you can go down that road as well. So I see where you ended up, especially when you said 2 different buildings and you've got enough load capacity on one set. So if you lost one of the, well, it's a sort of a type of a cluster at this point, then the other one could pick up the load that's remaining. It sounds like, right?
Yeah, exactly. And we are trying to hit our journey to 5 nines, some number of minutes of unavailability per year is what you would get with 5 nines. And different elements of our network can hit that, but depending on what level, the application layer, the network layer, the underlying plumbing, we're driving towards that. And I mean, because my university, we have public safety and police department, our own police department on this network. We have building automation control systems on this network. We have the regular campus. We have a school of medicine. We have clinical spaces where they're seeing patients. We have a small hospital that's part of the university that sees patients. So there are portions of this network that are doing more than just streaming Netflix to residential halls. Definitely, by far. In addition to all the other applications I can't even name, from admissions to class schedule. So it's a network that needs to be up. And I felt 2 separate F5s that we could separately maintain. And most of the time, you don't have an outage because something blows up a power supply. It's because you want to bring it down for a maintenance window to upgrade the firmware. Yep. I think we have, for switches and firewalls and routers and load balancers, I think we bring, as a team, I think we bring things down more often to upgrade the firmware than they just have a hard failure. So we have to plan around that.
So let me ask, though, like the original issue was you had a couple of PSNs and you told these switches and these wireless controllers, this group send traffic to PSN1, and these switches and these wireless controllers, group B, send this traffic to PSN2. And now you've essentially just duplicated this design, but you've put a load balancer in the middle. Isn't that just kind of back to square one?
Yes, in a way. But during that process, that design process, and we were still working with Cisco Advanced Services because we wanted them to bless the setup. Mm-hmm. And there's a bunch of smart folks over there too. So if they are able to say, yeah, this is a solid setup, then it's pretty solid. But during this period of time, I discovered the iOS XE feature of radius load balancing within the switch and wireless LAN controller software. And I said, hey, that is interesting. That means that within, say, a switch, and we have 2,000 of them, mm-hmm. Each switch individually decides, okay, instead of I have this primary and then I have this backup that I only use if the primary fails, I can have 6 listed and I will just round robin right from the switch. And then 2,000 switches are individually doing round robining decisions to spread the load. I said, I like that idea. I gravitated to it pretty quickly. And we did some initial testing with one switch on the floor that us and the engineers are on, and saw it in action and said, hey, it's doing what it was designed to do. And we were talking to Cisco Advanced Services, and they said, I don't know. I don't know about that. We've never done that before. Like, Cisco's a big organization, and different parts of Cisco don't necessarily know everything that's going on in other parts of Cisco, I think is what was happening, which you would see in any large organization. And they said, well, we've always recommended customers do F5s. Okay, but we see this other feature. It's in the software. Can we use it? And so we actually worked with them and said, okay, let's have 2 separate F5s, 3 radius servers behind each F5, and turn on the iOS XE radius load balancing to balance between the 2 F5s. And if anybody pulls up the blog, you see this progression of how I describe, like as I'm going from step to step to step. And this is the background of why we did these steps, is we wanted to really make sure that Cisco Advanced Services was on board with, hey, we like how this is turning out, even though we haven't ever seen any other client do it like this, even though this is our product that we developed. And so we worked with them closely to say, hey, let's try this out. So that's what we next did, is iOS XE based load balance. So, and our wireless LAN controllers are running, it's the newer controller that Cisco has that runs iOS XE software on the wireless LAN controller. Okay. So it's the same software base as the switches. And we turned it on and we were load balancing across 2 VIPs, which, ultimately load balances is across the 6 radius servers that are behind the VIPs. And those VIPs are the F5 VIPs? The F5 VIPs, right? Okay. And so after a while, because it was, that works. I'm not going to say, it works perfectly fine. But after a while, we're pouring a lot of syslogging into a product that we have where we can ingest all that syslog information, parse it, and get the messages from ICE telling us what the average latency is and how much load is on each PSN. And we were able to show our colleagues and my boss and Cisco Advanced Services, hey, this iOS XE system, feature works like a champ. Works great. Look at it. We're hitting all 6 PSNs fairly evenly. But was it the iOS XE devices making, it wasn't them making the decision on which PSN to hit, it was F5, wasn't it? Because F5 is still intermediate between 3 of your 6 PSNs, right? Yes. The switch and the wireless LAN controllers were choosing between 2 VIPs. Yep. So they were load balancing 50-50. Yep. And then the F5 was load balancing 33-33-33 behind, to their radius servers, which would give you a 6-way split, roughly speaking. But what that enabled us to do is prove out the feature that this iOS XE based radius load balancing works.
I know where you're going with this. Did you eliminate the F5s? Is that what's happening?
Yeah. So we actually got a conference call between Cisco Advanced Services and the Cisco ICE, like product manager and one of the engineers, and the Cisco Catalyst Switch iOS XE engineers. And we kind of got them both in the same room talking at each other. And the Switch Catalyst engineer was saying, yeah, we developed this feature and this is what it was supposed to do. And Yale is seeing it work correctly. That's because that's what we designed it to do. And the ICE person was going, oh, okay, we see it working too, because Yale has produced these graphs and this dashboard that shows exactly what's happening. And so I think all the parties were excited to say, hey, this feature works really well. And now we have a customer with thousands of switches and thousands of active users hitting ICE load balanced. So the F5s were still there, but we were using the iOS XE radius load balancing feature inside the Cisco Catalyst switch. It was not software that was developed. It was in the switch. So maybe there's something I'm not understanding here, because the way you described what the iOS XE is doing doesn't really sound like load balancing to me. It's just kind of failing over to the next possible instance. And that
doesn't really seem like it's
Oh,
splitting the load necessarily. It's more just this one didn't work, so I'm going to go talk to this one. And if this one works, then that's where everybody's going to go, right? And don't you just sort of get a
by default, you're exactly right. It just uses the first one listed. You can list 6 in the config,
Mhm,
6 radio servers, but it'll only use the first one until it fails. It hits the
mhm.
dead timer and it flips over to the second one. Oh, if that one hits the dead timer, it might flip over to the third one until you enter one command into the switch. I forget the syntax, but it's one command that activates this feature called iOS XE radius load balancing. And once you put this one command in, there's a couple parameters to adjust the bucket size or something. We just use the default parameters.
Mhm.
It's one command, and as soon as you put that in, if you have 6 radius servers listed in your config, it will round robin across all 6.
Basically doing the work of the F5 now. It's not the original. That radius behavior that you described is age old. It's worked that way in iOS forever. You put in a list of them and it sticks with one until it can't talk to that one anymore. Then it goes to the next one. So you're describing now round robining per request, which is a whole thing that switch has got to now track state. And you're actually asking that switch to do a lot of work. So yeah, I'm not surprised it hasn't been there until recently. But I guess the question then is, were you able to engineer out the F5s using that feature, or did you keep it where you're round robining from the switch between the two F5s?
So let me address one observation you just made, which is the switch is doing extra work. They actually put some interesting smarts into it. By now, I haven't looked at the source code, but the documentation is pretty detailed, and it tries to do things in batches. So it'll batch together like 20 different authentications, the first one, the second one, up to 20, and send it to just the first radius server. And once it's finished with that batch, it'll look at all the other radius servers. There's 5 others, and say, okay, who has the least outstanding queries or
Hmm.
in process radius authentications? I'll
Mhm.
pick the one that has the least outstanding, and I'll
Oh,
send the next batch to that guy.
way smarter than round robin then. It's actually
Okay, yeah,
doing some much more observational intelligent load balancing.
that
Okay.
makes more
It,
sense. Yes.
yeah, and if one radius server starts to get bogged down and it starts to form a queue of outstanding requests, it will just not use that one anymore because it's
Hmm.
got 5 others that are perfectly good for use. If you're in our normal operating conditions, there's not a lot of load, there's not queues forming. So it effectively lands in a round robin type of scheme.
Mhm.
But if one radius server starts to get bogged down for whatever reason, it'll start skipping that one.
Okay.
Yeah.
And this isn't putting too much additional traffic on the network just to find out which radius server to go to?
It doesn't test connectivity. It simply looks at its own outstanding queries
Ah,
and
okay.
says, if,
Uh-huh.
if I have outstanding queries to radius server number 3, I'm going to stop round robining through 3, and I'm just going to round robin across 1, 2, 4, and 5, and 6.
Okay, that makes more sense. It's looking at what's happening with the sessions it's currently got open or trying to open.
Yeah, and another cool thing about the scheme that they landed on is if one of those servers is not really dead, but just having a brownout, it's choking for some reason. It will shed load off of that because this round robining system is happening independently across 2,000 switches. So they're all going to start to figure out in roughly the same amount of time that radius server number 3 is not doing well,
Mhm.
or it's got more load on it than everybody else, and then it'll just start shedding load away from it in a very distributed fashion. So you have the advantages of being a distributed process that's happening versus a centralized process that might be happening with an F5. And I like the distributed process because there's no single point of failure, and kind of it's collectively the knowledge of everyone forms into one big knowledge pool of, all right, the third guy is not doing well. And so they start to shed load.
That's what was throwing me about this setup because I was thinking for something like load balancing, you kind of want to centralize that because you want a central intelligence that's understanding, incoming and outgoing loads and how to spread them across most efficiently. Whereas an individual switch just round robining through a bunch of servers is essentially acting in its own best interest. And if you have thousands of devices acting in their own best interest, that's not load balancing, that's just chaos. But it sounds like that there is this kind of I guess maybe an unintended effect of distributing intelligence the way they've designed this capability through your infrastructure.
Yeah, 2,000 people all acting in their own best self-interest actually ends up being not chaos.
Yeah.
You ever hear that psychologists have done this experiment at county fair? They'll ask, 10,000 people to guess the weight of a heifer.
Mm-hmm.
And it's everyone from experienced people from a farm that have worked on their farm their whole life to Joe random person that has no idea the difference between a chicken and a cow.
Mm-hmm.
And they'll all put in guesses and put it in a bottle. And at the end of the day, the psychologists take an average of all those guesses and they'll nail it.
Mm-hmm. That's
and
interesting.
It's an interesting philosophy challenge to see why crowds and land on the right decision. Now that's humans, but interestingly enough, these switches figure it out too.
Yeah, I guess I was thinking more like, a bunch of people trying to get into a stadium and exit, entry one is too crowded. So they all rush to number two and that gets too crowded. So they all rush to number three and then you just have chaos. But no, it sounds like, yeah, this distributed intelligence happened. So, and I guess the final uptake then is that you felt confident enough in this system to pull the F5s.
Yeah, so not yet. Confidence is built upon experimentation.
Yes.
You don't want to just herky-jerky shift from architecture to architecture. I think we took like a single building or maybe even a single floor, maybe a single building, and we peeled that out and said, okay, these 6 switches, we're going to list all 6 Radius servers individually, turn on the iOS XE load balancing. You're not going through the F5s anymore. You're going to hit the Radius servers directly, and let's see how you behave.
Mm-hmm.
And that showed us the load balancing in action, 6-way load balancing, not just 2-way load balancing. And so we said, okay, that works great. Let's try, another building. And then we tried an entire wireless LAN controller that was handling many, many, many connections. And that worked great. Actually, our other vendor that we're migrating off of for wireless, they had a load balancing feature. I'm sure it's implemented slightly differently from how Cisco did it, but they had a load balancing feature. We turned it on in that platform, and that worked well. So we went through that process, and telemetry and data gathering and understanding how the network works is critical because you don't know what you're doing if you can't measure ahead of time and then measure afterwards and see the behavior of the system. I'm a huge fan of measuring and analytics and the proper, whether it's SNMP or something more advanced, you got to have your finger on the pulse of what's going on. And so after that initial tests, we pulled the F5s and all the switches and 2, 4, 6, 8. I think we have 10 wireless LAN controllers handling different areas of SD access, are all going directly to all 6 PSNs. And we measure the load, and it's not perfectly balanced within like 1%.
Sure.
But that wasn't the intention. That wasn't the goal. It load balances within 25%, give or take. And we have had a point where we did take PSNs down for maintenance because you upgrade the code, like a maintenance window. And we'll take one of them down, upgrade the code, and we can see from the graphs in real time that all the load sheds off that PSN and drops to 0. And the other 5 PSNs pick up the slack. We finish upgrading the code. We bring it back online. And then load ramps back up on that PSN and bounces across. And then we repeat 5 more times to get all of them upgraded.
Now you raise another question. You were able to do this because of this feature in iOS XE. But yeah, I think you said you also had a different vendor that also had this capability. But I'm curious if I was in a heterogeneous environment, could I get away with it, or would I still need to have the load balancers in place?
Without your vendor being able to do the load balancing from the gear, you would absolutely be needing an F5 or a Citrix load, or A10 or Kemp or whatever.
Sure.
One of the things we did notice when we were speccing out the F5s, which helped the process, is F5s and other load balancers excel at doing HTTP, TLS, decrypt, re-encrypt, and doing a lot of state tracking, a lot of different proxying functions. Here, we're just trying to round robin some UDP sessions.
Yeah.
Right.
So even the smallest platforms, maybe not the smallest, but like the second to smallest platform the F5 had is the one that we ended up buying because the horsepower of that thing was well in excess of what we needed to do just to round robin some UDP packets. So that was good. Yeah. So, you would there'd be no way around it. Without this feature, you would need an F5 to scale out.
Yeah.
With this feature, the F5 has no value proposition for you. It doesn't do anything. That's what our data suggested. And we're happy with the setup. And the care and feeding of the F5, gone.
Right.
because
Yeah.
it's not in the system anymore. When you can remove components from an architecture and the architecture is perfectly fine without, the same, that's a win.
Yeah, absolutely.
For sure.
Although I'm wondering, you bought two F5s. They're known to be spendy. Did after saying, "Oh, now we can pull them," did somebody from the budget office come down and have a visit with you about that?
No, thankfully, no. They're in our lab waiting for their next assignment, which may or may not come. The cloud team certainly could ask to use them. So we haven't had a new project for them. But like I said, we bought like really small units, so that was to our benefit.
Oh, okay, because you weren't needing to do, TLS interception and decrypt and so on, so you could buy sort of the lower end, less expensive devices.
Yeah, on the spec sheets, the UDP or just simple load balancing functions, that line on the spec sheet is an order of magnitude higher than the full SSL
Yeah.
TLS decoding, re-encoding like line item.
Yeah.
So you can totally get away with a lower end box, which we did, and it was fine. Like the lower end box had plenty of horsepower for thousands and thousands of sessions. You need a bigger box when you start to do TLS and proxy functions.
For sure.
Yeah, so it's also part of a huge, bigger project too, because the SD access rollout across these 300 buildings and multiple years of project teams and effort. So I don't know how much of a dent on that big budget. I mean, it didn't dent the main budget, so that was good. We're trying to. We obviously we're good stewards of the resources that we have,
Of course.
but when it comes to a better system that's going to have fewer abnormalities or fewer outages per year because you've removed components that needed care and feeding, nobody's going to say, no, put the F5s back in. They're not.
We paid for them. You're going to use them.
They're not amortized out on the ledger yet.
And I'm guessing the spend on the SD access is probably providing cover for, budget-wise, a lot of things like that. It's a big number, I'm guessing.
Yeah, Cisco is a great partner. And they've been working with us directly with the SD access rollout, which is a whole nother topic. I mean, that's a big topic right there. It's a product that is giving us a lot of benefit over and above the old network architecture we had, which was showing we needed a new architecture on the campus to suit the needs of all those other components and departments that I mentioned previously. We have some high-end science going on with large data sets. They send data back and forth to CERN, and we have a quantum lab going in. So the network is going to be a huge player in some of the university's endeavors. Mm-hmm. So this big new campus network is going to play big dividends. We're using a lot of 25 gigabits per second Ethernet with 2 uplinks where buildings used to be serviced by 1 gig. So yeah, it's a big project.
25 gig in the campus?
Yeah. We use, when we have a CAT 9400 chassis, we do 2x25 uplinks to an intermediate pair of nodes. If it's the smaller CAT 9300L, we do 2x10s because that's what that platform does. So it depends on what kind of closet and what the density of the closet is.
Nice.
I think overall, this F5 architecture and the resulting load balancing from the switches it comes under a broader category of how we look at systems as engineers, which is a big part of what I've been trying to work on as an architect and as an engineer. And the HA pair phenomenon. When people say that it can't, there's 2 of them, so you're good. That's the redundancy, right? Sometimes we take it for granted. Oh yeah, that's good. I mean, if I said that the only way a data center could possibly fail is if the power and the air conditioning failed at the same time, and what is the chances of that happening? No, everybody would realize that's a crazy comment because they're coupled systems. Like one's going to fail if the other one fails. Like they have a shared state there. But if the other hand, I said, well, there's 2 firewalls, and the only way that internet access for the entire organization would fail is if both of them failed. And what are the chances of that happening? Sometimes we kind of, nodding, oh yeah, we assume that these systems are well designed and they're loosely coupled and that they don't share state or they won't both go down. And I always want to make sure that I'm challenging my colleagues or people that we talk to in the industry to say, hey, is that really true? Like, how do we design systems so that we are driving towards those 5 nines of reliability?
Right. I think it's also interesting that your primary vendor had a capability that the vendor itself didn't really even know about. You sort of stumbled across it and were like, hey, can we use this? And they were like, I don't know, let's check it out.
The vendors are, the IT scene is constantly changing and it's in flux all the time. And it's one of the things that I really love about this field. And so it's a moving target. And you're also in a pickup truck and the target is moving and you're moving. So the network engineering and IT in general is you have to stay on top. When vendors say that something is true or something is the case, I mean, they're not trying to lead you astray or give you bad information, but the whole picture is needed.
Mm-hmm.
And as a systems architect, we're called upon to make sure that we're designing things that are robust. I like the term anti-fragile because you're trying to design systems that actively resist breaking down when one of the components break down. So that's what we're driving at. I'm always struck by the idea that civil engineering, mechanical engineering, these fields have been around for, thousands of years, and even electrical engineering, which has, not been around as long, but has been around much longer than computer science and the IT infrastructures that we build today. And they know that you cannot build systems that have only a 97% success rate or only, they're trying to build systems that people's lives depend on, that infrastructure, that cities are built on, and their fields have a lot more maturity, I feel, than the computer science and software and some of these IT systems that we build. And so we need to step up to the bar as network engineers, I feel, and really challenge ourselves over the next decades to come up to speed and build robust, reliable systems.
I can get behind that sentiment 100%. Yeah, I think it would be nice if the vendors also thought that way.
Yeah, code quality is a struggle.
Code quality is number one, probably, yeah.
Sometimes there's a constant barrage of new features, and I sometimes don't want the features. I just want you to make it even, more robust,
right,
or less resistant to failure. And consumer grade stuff that's connecting to our network is on another whole level of poor code quality. So that's our main problem is anybody. So at a university, it's a lot of BYOD that you would not see that much BYOD at, say, an enterprise network or in healthcare or something. So that throws a huge variable into the system. And it's an exciting variable because it really pushes you to design systems around unknowns.
I feel like you've come up with maybe a new metric we can implement in the networking space, which is active failure resistance, ARF. So let's push that.
Yeah, HA pairs of whatever it is can get into split brain as well.
Yeah,
they're fighting each other, trying to decide who should be forwarding traffic and who should be. It happens with any HA technology, and we have to go in there. We have to go into an HA setup because I use them actively in our current network. HA pairs of whatever. So it's not like you can avoid it, but you want to go into it with your eyes open and say, okay, here's my failure modes. Here's how one will fail, but the other one will survive. What can I do to make sure that happens? So it's a challenge.
Well, Dan, thank you for coming on to share your experiences. I really enjoyed this discussion. If folks want to find you online or get in touch with you or whatever, or see what you're up to, where can they go?
I am on LinkedIn, so people can hit me on LinkedIn. I don't do a lot of social networking, so I think I am on X, but you'll never reach me because I never check it.
Okay. And as I mentioned, this episode is based on some blogs you wrote. We'll have the links to those in the show notes if folks want to read up on it. Ethan, where can folks get in touch with you?
LinkedIn's the best place for me. Just look for Ethan Banks. You'll find me there. And I post nerdy stuff to try to help you keep up with what's going on in IT.
Absolutely. I'm Drew Conry Murray. I'm also on LinkedIn. And if you want another way to reach out to us, Packet Pushers has a Slack channel. You can join for free, hang out with a bunch of other network engineers and infrastructure nerds. You can ask questions, get advice, share memes, and just generally come and hang out and have fun. That's all at packetpushers.net/Slack. Thank you so much for listening. We value your time. We appreciate your time. We hope you found this useful. If you want to find out more about what we're up to, check out packetpushers.net. We just redesigned the site, so come and have a look. If you haven't been in a while, check it out. And we welcome your feedback and comments. And as always, remember that too much networking would never be enough.